constraints to our views. We know how to pin any edge of a view to any edge of any other view, or to any edge of the parent, the constraint layout itself. So in this tutorial, of adding opposing constraints. What happens if you pin opposite sides of a view to different things? So I'm in a new layout file called constraint layout 2, and I've made sure that the root element is constraint layout. So if you can go ahead and do the same. So the first thing that I'm going to do this time is add an image view to the top of the screen. So if you can go ahead and make an image view tag, capital I. Now one thing that I want to quickly show you is actually you can make any of the views inside a constraint layout be match parent. If I say width match parent and height match parent, you can see with the blue box to the right it does fill the whole screen, and we don't get any warnings. And the reason we don't get any warnings is the constraint layout knows where to place this view. It knows to fill the whole box, the whole container, so we don't need to add any constraints for match parent. However, for this image view, I do want the width to fill the screen, so layout width match parent is fine, but I want to fix the height to something like 150 dp. And we get a warning saying it's not constrained vertically. It's not complaining about a horizontal constraint because it fills the width, so that's not an issue, but we do need to constrain it vertically, so I'll simply say top to the top of the parent and pin that to the top of the screen. And just so we can see something in our design preview, I'm going to give it a source, so src, and I'll just choose drawable and the launcher background, that default background to our app icon. A pretty ugly green, but at least we can see something. And just to make that fill the image view, I will add scale type, and I'll say center crop, so that will enlarge it until it fills the whole image view. So it looks a little bit low resolution, but for the purpose of this tutorial, we can see something in the design preview filling the image view, and that's exactly what we want. So we have an image view with match parent width filling the space, but we've constrained it to the top of the screen, top to the top of parent. And I'm just going to add an ID, so ID image underscore view, and then auto format. So what if we wanted to place a button directly under this image view? Would you remember how to do that? Go ahead and pause the video, create a button with some dummy text, and place it directly underneath this image view. Doesn't matter if it's on the left or the right, just make sure it's underneath. So the way we do that, button, we'll do wrap content, we'll do some dummy text, test button, self-closing tag, and we would do the top of the button to the bottom of the image view. And you can see that moves the button down. And we should probably constrain this horizontally. I'll leave it at the start, so I'll do start to the start of the parent, and the error goes away because we constrained it both vertically and horizontally. Of course, if the width was match parent, then I could delete this horizontal constraint, and no error because it's filling the width, okay? So that's a new concept there. You can use match parent inside a constraint layout. But I'm going to undo that, so I'll undo the layout constraint, I'll undo the match parent, so wrap content. Now at the moment the button is quite close to the image view, something we didn't cover in the previous tutorial. It is still possible to add layout margin exactly like our other containers, so I'm going to give this some layout margin top and something like 24 dp to give it a bit of space. And when we apply the margin like this, you can see now that arrow showing us the constraint, this curvy arrow here, that shows us the top edge of our button pinned to the bottom of the image view. And of course if I made it quite big, like 200 dp, then it doesn't need to curve so much, okay? So I'll undo that, leave it at 24 dp. So how would we go about centering this button horizontally? We know we don't have any layout gravity attributes. We can't do layout gravity center. That's for linear layouts, okay? And also if I start typing the word center, S-C-E-N-T-E-R, there's actually no attributes at all in a constraint layout that will control whether the view is centered. So this is where the concept of opposing constraints comes in. We have pinned our view to the start of the screen. Of course I can remove this, I can change it for end to the end of, and then it jumps to the right. But see what happens if we constrain the end of the button to the end of the parent, and the start of the button to the start of the parent at the same time. So go ahead and do this, have an end to the end of constraint, and a start to the start of constraint, pin both sides, the opposite sides to the parent. And you can see our button is now centered. And the lines showing where the constraints are, the line going from the edge of our button to the edge of the parent, they now have a zigzag. And that zigzag at the start and the end of the button is showing you that this button has opposing constraints. It's being pulled or constrained in both directions. And the default behavior for when you add opposing constraints is it will center the view between those two constraints. And this becomes quite a powerful thing. So we'll go ahead and add one more view in this tutorial to show the power of these opposing constraints. Underneath the button, go ahead and add a text view. Make the width wrap content and height wrap content. And do a little bit more text. We'll do text. This is my example text view, or anything you want. Do a few words. And self-closing tag. So as a quick test of what we just learned with the button, how would you go about centering this completely in the middle of the whole screen, both vertically centered and horizontally centered? Have a think, try it yourself. The way we would do this is we would add opposing constraints to the start and end. So I do start to the start of parent and end to the end of parent. And even though it's sitting on top of the image view, you can see there, that's now centered that horizontally. And we have those zigzaggy lines showing the opposing constraints. But if you also do the same for the top and the bottom, top to the top of parent, and also bottom to the bottom of parent, then you can see we have zigzags on all four sides, two pairs of opposing constraints. And by constraining every edge of the parent to the container, that makes it exactly centered both horizontally and vertically in the container. And as the container matches the screen, that's centered exactly in the center of the screen. But the power of these opposing constraints is more evident when we start to put opposing constraints not always on the parent, but in relation to other views. So now we want to leave this text view centered horizontally, like we've done, so you can leave the opposing constraints for the start and the end, leave them constrained to the parent, that's fine. But now we want to place this text view halfway between the bottom of the screen and the bottom of our test button. So if you think you can solve this yourself, go ahead and do it now. But now we want to place this text view halfway between the bottom of the screen and the bottom of our text. Using constraints for the start and the end, leave them constrained to the parent, that's fine. But now we want to place this text view halfway between the bottom of the screen and the bottom of our test button. So if you think you can solve this yourself, go ahead and do it now. If you're not sure, we need to delete our top to top of parent constraint, so we'll delete that. And the text view jumps to the bottom, because it's got no opposing constraints now, so that bottom to the bottom of parent will bring it all the way down. But if I now add another constraint to the top of our text view, so I'll start with the word top, the top of our text view, but I'm now going to pin it to the bottom of the button. I've just realized that I need an ID for my button, so I'm going to go ahead and add the ID, just call it button. And then if I go to my text view and add a constraint top to the bottom of the button, you can see those zigzaggy lines going from the bottom of the screen to the bottom of the test button. And that text is now perfectly centered between the button and the bottom of the screen. And this is the power of opposing constraints. And this becomes incredibly useful when we talk about the concept of responsive layouts. You may or may not have heard the term responsive, particularly when browsing websites on a mobile phone. But when we talk about responsive user interfaces, responsive layouts, we're talking about that the layout will respond to whatever shape, whatever orientation, whatever size screen the user is using. So if we now, in our design preview, next to the blue icon, click the orientation for preview icon and select landscape, if I bring this across to zoom in a little bit, you can see that even though we're in landscape, because we've used constraints and this powerful technique of opposing constraints, even though it's a totally different height of the screen, the text is still centered between the button and the bottom of the screen. And when I change it back to portrait, it adjusts automatically. So using the constraint layout container in Android is one of the best ways you can make super responsive, super flexible layouts. So whatever size phone, whatever orientation the user is using, by using constraints well and using opposing constraints to place things in the middle of other things, your layout is going to be able to handle any device, any orientation. Okay? So that is the concept of. So the third and final of our essential constraint layout skills involves a concept called match constraints. We know how to add a constraint and pin any edge of our view to any edge of any other view, or the parent. And we know that we can use opposing constraints to add a constraint to each side of a view, and that can be used to center a view in the middle of two other views, or the parent. We also touched upon the concept of responsive layouts, layouts that respond to whatever size or shape the screen is. But what if we want to use the constraints that we've added to our view to determine the size of that view? So the concept of match constraints can be done to achieve this. We can add constraints to opposing sides of a view, just like we did in the previous tutorial, but rather than leaving that view as wrap content, we can actually match the constraints, and that view will stretch to fill that space. Let me show you what I mean. So I'm in a third and final layout file called constraint layout 3, if you can go ahead and do the same, and this time I'm going to close the project pane to have a bit more width. Okay? And the first thing I want you to add at the top of the screen is an image view, like before. So image view, and for now, do width match parent and height 200 dp. We'll need to give it some source so we can see what's going on, so we'll give it a source of the IC launcher background, like before, and we need to give it an ID. So ID, we'll just call it image view. And a self-closing tag. Straight away we're getting a complaint because we haven't added a vertical constraint, so if we do top to the top of parent, the warning should go away. And this time I'm not going to do scale type center crop this thing. I'm happy for the image to be only as wide as it needs to be for the height that we've provided. So by deleting the scale type, we can see that, okay, it's not quite full width, but that's absolutely fine. And if I just quickly do an auto format to bring the ID to the top. So at the moment we're using match parent for the layout width, like we did in the last tutorial. And this is okay, it's a quick and easy way to fill the width of the screen or the constraint layout, the container, or the height. But strictly speaking, we're not actually supposed to use this. There are some warnings on the official documentation that we shouldn't use match parent, that it can occasionally throw some anomalies, as this view group, this container, is expecting constraints. It's expecting the edges of our views to be pinned to different things. In my experience, I have used this in some personal projects and indeed at work, and match parent seems to work absolutely fine, but I just thought I'd mention that to you. So then if I'm telling you now that we are not supposed to be using match parent to fill the width, then what should we do? Well, what we should really do is we should do start to the start of parent, end to the end of parent, okay? And rather than layout width match parent, if I just delete that value, we're supposed to type something which says match the constraints given, match constraints. And the way we do this is by setting the width to be 0 dp. Okay? And when we do this, we're telling the constraint layout to determine the width automatically from the constraints. Match the constraints given. If I set the width to something fixed like 300 dp, you can see that shrinks in a little bit, and because we have opposing constraints, it's centered, okay? And I can do 150 dp like that. But when I do 0 dp, it will match the constraints. It will go all the way to wherever the constraints are. And this is the correct way to do the match parent effect, according to the documentation, okay? I'm just going to apply some padding to the constraint layouts to squeeze everything in. Also just to show you that padding works absolutely fine on a constraint layout. So you can see there we have padding there, and that works on all sides and all of our constraints. So I'm just going to quickly auto format. Let's now use the concept of match constraints to not just fill the width of the screen or the container, but let's use the concept of match constraints to fill the space between two views. So let's add two more views now to our screen. Let's go ahead and add a text view. And we will this time use wrap content for the width and wrap content for the height. And we'll just say for the text something like my example title. And we'll give it an ID because we're going to need to constrain other views to this. So text view title. And we will constrain the top of this view, so top to the bottom of the image view. and that jumps down, and we want it centered, so I'll do start to the start of the parent, end to the end of the parent, and that then brings it to the middle using those opposing constraints you can see there. And finally, we will give it some margin to the top, so margin top, and we'll say 12 dp, just give it a bit of space from the image view, and a self-closing tag, auto format. I'm also going to add a button to the bottom of the screen, so go ahead and add a button. This time I want it to fill the width, so we'll do 0 dp, we're going to match the constraints for the width. The height, we can just wrap content as normal for a button, and we'll give it some text, we'll say submit, like a submit button. And this time we want the bottom to the bottom of the parent, so that jumps down. And we want it to fill the width, we want to match constraints, so if you do start to the start of parent, and end to the end of the parent, well, that stretches because we have the 0 dp. We're saying match the constraints given for the width, okay? I could delete those constraints and change this to match parent, and Android Studio won't complain, it seems to work absolutely fine. Just do note that in the official documentation, they don't advise using match parent. They much prefer using 0 dp. And the constraints. Okay, so that's a text view and a button. I will need to give the button an ID, so we'll just call it button for now. So using the concept of match constraints, I want to place a text input layout, as well as a text input edit text, inside the space between the text view and the button. Okay, so I want the width of my text input layout to fill the screen, so end to the end of parent, start to start of parent, and match constraints. But I want the height to be determined by the space that's between my example title, you see there, and the button at the bottom of the screen. So if you think you know how to do this, you can pause the video and jump ahead and try and give this a go. That'd be a really good test to see if your first instinct is correct. The reason I want to use a text input layout is because if we change the style to outlined box, like you've seen before, that will show it nice and clear on our design preview how much space the text view is taking up. The edit text would just be an underline, it might not be so clear. So use a text input layout, set the style to outlined box, give it an edit text on the inside, and give the text input layout a hint, all the things you should know how to do by now, and try and constrain it in between the text view and the button, and use the 0 dp for the height to match the constraints for the height. If you're not sure what to do, or you want to see the solution, let's go ahead and do it together now. So text input layout. You can see that there when I select it. So there's the layout container. I'll use 0 dp for the width and 0 dp for the height. I'm going to give it a hint that says this can be our multi-line text field, exclamation mark. I'm going to set the style to be text, input, layout. You can see that autocomplete, and then I'll do outlined box. And my font is quite big, but you can just about see that when I select it. So that one there, and then I can do a normal right arrow to give me the closing tag, and inside the closing tag, I'll do my text input edit text. Okay, this time I can do match parent and match parent. The size is being denoted by the text input layout, the container outside it. So in this case, I want the edit text inside our text input layout to be match parent. Okay, and now it's time to add our constraints. So I want the start to be to the start of the parent, and the end to be to the end of the parent, so that will match the width. And now I want to constrain it in between the bottom of the text view and the top of the button. So the top of this text input layout to the bottom of the text view. And you can see that jumps down. But also the bottom of this text input layout to the top of the button. And there you have it. If I just click off this, you can see it. We have a text input layout that fills the space in between the text view and the button. I'll give it some margin top, maybe 12 dp, and some margin bottom, 12 dp. I don't want any margin at the start or the end because the padding takes care of that in the parent in the constraint layout. If I just do a quick auto format and select off this, and that is now filling the space. We are using match constraints to put that in between two other views. So now if I turn this into landscape by clicking the orientation for preview and selecting landscape, it responds to the space it has available. It's a responsive layout. So that is the concept of match constraints. You specify 0dp for the width or the height, and that tells the constraint layout, I'm not going to give you a width, you determine the size based on the constraints that I give you. And that's how you can make what's called a dynamic size. It will be determined dynamically depending on how much space is available. It will respond to the available space. It is responsive. It's a responsive layout. Just as one final little bonus, if I just turn this to landscape again, you could argue that the 200 dp that we gave the image is pretty big in landscape mode. It doesn't leave us much to work with. You can see our multi-line text view doesn't look multi-line at all. If I turn it portrait, it's absolutely fine, okay? So is there something we could do? Rather than specifying the height in pixels, could we make it a proportion of the screen? So if I just scroll up to the image view, so we're saying 200 dp there. And the answer is, yes, we can. So wouldn't it be nice if rather than saying 200 dp, it was approximately, I don't know, 25% of the screen? So there is a way to do this, and it's incredibly easy. Change layout height to 0 dp. So we're saying now we want it to match the constraints given. And there's one more attribute we can add. If we type the word height and then percent, layout constraint height percent, we also have width percent as well, you can see, okay? But if I do height percent autocomplete, and I can specify a decimal between 0 and 1. So if I say 0.25, that will be 25% of the screen, whatever space is available. Please note, if you're using a height or width percent, you must have 0 dp. You must tell the constraint layout to match the constraints. We're giving it a constraint, 25%, okay? So now if I turn this design preview to landscape, it only takes up 25%, and our multi-line text field looks a lot nicer. Okay, so that is the concept of match constraints. With a bonus concept of width or height percent, you can now pin any edge of any view to anything else on the screen, whether another view or the parent. You can use opposing constraints to center a view between two views, and you can use 0 dp match constraints to determine the size by those constraints for a truly responsive and dynamic layout. Fantastic. So let's now apply all of this learning, go back to our project, and build out our main activity layout using these skills.